Hello everyone. So I have selected a number of DC circuit problems, so let's go ahead and get started. First problem 1.1 is asking to find the inductance, the equivalent inductance. So remember that for inductance they act like resistors when it comes to finding the equivalent resistance. So when you have parallel, these two are in parallel right here. These two inductors are in parallels, and these two are in series. Okay, so I'm gonna go ahead and add these two, just like resistor rule. So we have 15 plus 5. This is 20 henries, and these two are in parallel, so I have 10 times 10 over 10 plus 10, and this is equal to 100, sorry, I was adding, but this is 10 times 10 is 100 over 20. Of course that's 5. Okay, so now we have this is what we have. This is the 20 henries inductor here, which is this one, adding them to, and then we have these two, which is 5 henries, and so of course these two are in a series, so LEQ is equal to 25 henries. Final answer. Okay, all right, so moving on to capacitors. Problem 1.2, find the capacitance, the equivalent capacitance. So these three are in parallel. So remember, capacitors and resistors, they're opposite when it comes to finding the equivalent capacitance or resistance. So resistors, they would put 1 over 1 over 1 over, but for capacitors we add them together. So these three are in parallel, so this total would be 1 plus 1 plus 1, that's 3 microfarads, and so you have the 2 microfarad is going to be, let me write that down, so you have the 2 microfarad, which is gonna be in series with the 3 microfarad. So these are in series, and so the C equivalent would be 2 times 3 in series, right? Okay, so over 2 plus 3, so this is equal to 6 over 5 microfarads. Okay, so that's the final answer, I think. Yes. Okay, so moving on to another problem. Okay, so what do we have here? What is the where's my Alright, so what is the voltage across the 5 ohms resistor in the center? So over here, they're asking us to find the voltage across this particular resistor right here. So what's voltage? Voltage is equal to IR, Ohm's law. Okay, so we know what R is, but we don't know what I is, the current. So how do we find I? Okay, so we could start using KVL. So we can pretty much start dividing our current. So let's assume that I1 goes through that one, and I2 here. And remember KCL is the sum of currents going in or is equal to the sum of the current going out. So which means that the current here, so you would have, let me write that down, so you would have I1 which is going in is equal to I2 plus whatever here. So this current here would be I1 minus I2. Okay, right, so this thing is I1 minus I2, that's what I wrote here. So now applying KVL to find our current going in here, I1 minus I2, we can apply KVL and have two unknowns. So applying KVL, we have, let's go ahead and do that. So from minus to plus, KVL says what? All the voltage, let me put that, sum of voltage drops is equal to sum of voltage rises. Okay, so from minus to plus is the voltage rise, so we have 10 volt, it's a plus. Okay, so here would be a plus, minus, let's put the signs, going from plus to minus, going from plus to minus. Okay, so from minus to plus is positive, right? Because you're going to positive, so it's positive, so plus 10 volt. From plus to minus, it's gonna be minus 5I1. We're dealing with voltages here. V is equal to IR, so minus IR, so 5 volt I1. Okay, so here would be plus to minus, so that's going to be a minus 5. And what's the current? Current is I1 minus I2, and this is equal to 0. And of course that's the first loop, that's this first loop here, this one here. Now we're dealing with this two loop, the second one. So going from minus to plus is plus, so we have 5 I1 minus I2. Going from plus to minus, that's minus 5 I2, and this is plus to minus, so that's minus 30 volt. It's equal to 0. So we just have to rearrange this and find our I1 and our I2. So we have two equations with two unknowns. Let me rearrange them. So I would have 10 is equal to 5 I1. I'll just put everything, not just work it on my head. 5 I1 plus 5 I1, it would have been, okay, minus 5 I2. Here would be 5 I1 minus 5 I2 minus 5 I2 is equal to 30. Oh, this is messy. So let me put everything in perspective. So I would have 10 I1 minus 5 I2. I'm just rewriting it to make it more simple. So this is equal to 10, so that's equation 1 over here, it becomes this. Okay, and at the bottom we have, what do we have? We have 5i1 minus 10i2 is equal to 30. Okay, so what's I1, what's I2? Let me multiply at the bottom by 2. This is equation, two equations, two unknown. So if we multiply by minus 2 here, and then we add, so that'll be, this will be gone, I1 will be gone because you have 10 minus 10, but then you have minus 5i2 plus 20i2, so that's 15i2. Yes, 15i2. 10 minus 60, that's 50. That's minus 50. So this is equal to minus 50. And therefore, I2 is equal to 50 over 15. Minus 50 over 15. And you guys can peer check me too, because I'm doing this live pretty much. So this is 5 times 10. This is a 3. So this is minus 10 over 3 amp. Okay, so I2 is minus 10 over 3. Right, so now we go ahead and find, so I2, let me put that here, I2 is minus 10 over 3 amp. So now let me find I1. Scroll down a little bit. Okay, so how do we find I1? I can go ahead and in this equation I can go ahead and plug in minus 10, 30, but that would be hard because it is fraction. So I'm gonna just act like I didn't know what I2 is and just try to find it from here originally. I mean, you can solve this any way you want, because this is really like elementary algebra right here. Okay, so I'm gonna act like I don't know what I2 is, and so to find that I would have to multiply here by minus 2. Okay, because I don't want to deal with fractions, I just want to just find the answer straight. Okay, so I would have, so if I multiply this part here by minus 2 and then I add them together, I would have minus 20 plus 5, that's minus 15 I. So of course I2 will go away because you have plus plus, and so you have minus 20 plus 30, which is 10. So this is equal to 10. And so I1 is equal to 10 over minus 10 over 15. And this is minus 2/3. Okay, so I1 is equal to I1, let me change the I1 was found to be equal minus 2/3. Oops, what a 3. Looks like a 5. So amps. Okay, so now we know what I2, still not that thick. Okay, so remember that the current going through the 5 is I1 minus I2. So we have I is equal to I1 minus I2, and this is equal to minus 2/3 plus 10/3, right? Because minus minus. So this is equal to 8/3. So I is equal to 8/3 amp. Okay, so now we know what I is and we know the resistance, so we can go ahead and calculate our voltage, which would be final V is equal to 8/3, we know I times 5. So that's 40/3 volts. That's it. Isn't that fun? Alright, so let's kind of put everything together. So the question was to find the voltage across the 5 ohm resistor. So always start with what's the question. So the question is voltage. So what's voltage? By Ohm's law, voltage is IR. We know we know R. We don't know what I is. To find I, use KVL. The current going through the 5 ohm here is I1 minus I2. So once we know what I1 is, once we know what I2 is, we just subtract them together, find I, and go back to our original equation here and just put it there. So that's the final answer, 40/3. And you can peer check me too, and if you don't have the same answer, you can just put it in the comment section and let me know. Okay, next problem. Okay, so what are the Norton equivalent source and resistance values for the circuit below? Okay, so Norton source, and so this is asking for I Norton and R Norton. So R Norton is the equivalent resistor. So we have to assume that all voltages are 0. So if we eliminate those, we are left with only, so act like this is gone and that's gone. So we only have a parallel circuit between R1 and R2, and so Rn is equal to, it's a parallel because of this, but it's because of this node over here. Okay, so it's not series, it's parallel. So we have 10 times 10 over 10 plus 10. So this is 100 over 20, and this is equal to 5 ohms. So our first answer is that. Okay, so to find that, we had to turn off all the power sources. So we have to short circuit the voltage sources here. So we act like these are not even here, and in that case we only have this, pretty much like a parallel circuit between these two, and that's why I put them. So to find the Norton equivalent source, the Norton resistance value, we have to short circuit all the voltage sources, all the power sources, we have to turn them off. Okay, so now to find IN, so no current will flow through R1. Why? Because the terminals of R1 are short-circuited. Okay, so the terminals here, they're short-circuited, so there's no current flowing through R1. That's Norton right there. Okay, because it's this is B, terminal A through B. So the terminals of R1, these are short-circuited, so there's nothing that goes through here. There's no current going through here. So if we apply so now we put the sources back together after we find the our resistance. We turn the power on, short circuit the terminals, okay, and apply KVL. So KVL, so from a minus to plus, it's positive, so we have 20 volts. Plus to minus, that's minus 10 volt. There's nothing that goes through here, okay, absolutely no there's no current flowing through that because it's short-circuited here. So we have this for the voltage. We'll have R2, so this is a plus to minus, so there's a minus sign. 10 IN equals to 0. So there's a short circuit. With Norton, there's a short circuit across the terminals, so there's no current flowing through R1. Remember that, okay? So now we are left with this, and so we can find IN. Remember, the question was to find IN AR, and now we know everything here. So we have 20 minus 10, that's 10, is equal to 10 IN, and therefore IN is equal to 1 amp. Okay, so to put everything together, to find the resistance value, we have to shut down all the power sources. So the 20 volt is gone, the 10 volt is gone, we turn it off. And once we turn that off, we find the left over, which means the circuit is just R1 and R2, which are in parallel, and we find that. And so there's a short circuit. To find IN, there's a short circuit across AB, so there's no current flowing through R1, and therefore it's only we apply KVL, and we find our IN. That's it. Okay, another problem. Okay, so this particular problem, what are the voltage across and current through the 5 ohm resistor in the center leg? Okay, so there's an IX here, so that's the current flowing through 5, and they're asking us to find IX and the voltage across 5. Okay, how do we do that? Oops, I have a capacitor. Remember, in my previous video, when you have a capacitor in a steady state, because here the circuit is a steady state, it was indicated here. So the capacitor, there's an open circuit, there's no current flowing through that. Which means that this part right here is gone. It's gone. Okay, so there's nothing going through there, and so we can just apply KVL again. So if you don't notice that, if you don't remember that there's no current flowing through the capacitor at steady state DC circuit, then you're gonna struggle here, because you're gonna be like, okay, KCL current here, here going in, and then you're going to struggle with the capacitor here. So that's a rule that's very important. Okay, so this current here, IX, is also the same thing as this one here. It's a simple circuit. We've talked about it in the previous video. So this current here is the same thing as this current here. So we just apply KVL. So from minus to plus, it's plus 10 volt. Put my signs. Plus, minus, so it's from a plus to a minus, so that's minus 5ix. Here also it's plus minus, so that's minus 5ix. is equal to 0. Okay, so we have 10 minus 10 ix, so that's 10 ix. Therefore, ix is equal to 1 amp. So there's 1 amp going through this. So we already find one of the answers. So now to find the voltage is pretty easy, right? V is equal to IR. We know what I is 1, already found it. We know what R is given is 5 ohms. So therefore voltage is 5 volt. So that's it. So stay tuned for other examples. So I'm going to stay in DC circuits, so I'll find other problems as well to solve. Let me know if you have any questions, and if I don't forget to also peer check me and put that in the comment section. Thank you very much.